Today we'll be covering cybersecurity for electric utilities. We're going to cover 3 key areas of security and then follow with a Q&A session. Speaking today is Mark Dam. He's our founder and CEO. He's got 30 years experience implementing and operating complex systems for critical infrastructure. He's experienced in the architecture and development and deployment of IT solutions and has been working with many utilities in the past. And as such, he's an expert in various areas, including cybersecurity. So just to keep us moving, I'm going to hand it over to Mark now.
Hi everyone, welcome to presentation. Give you a little background of FuseForward. FuseForward, our team has been working together for over 20 years, working with utilities, municipalities, and large enterprises across the globe, actually. We currently work with organizations throughout North America, including cities in Vancouver, Portland, Oregon, consumers, gas utilities, as well as areas like Seattle City Light and a number of other electric utility organizations. For these organizations, what we've typically been doing is building out their asset management systems, integrating in with their spatial GIS, their real-time SCADA systems, and understanding how all of them are put together and how you manage all that asset portfolio in those production operations. With that, we've learned a lot, and part of what we are now doing today is helping to share what we've learned with our customer base and with the market on how we can go through and help you secure your electric utility. So let me give you a little background of the electric grids and some of the challenges that we run into today. There's always been that one area that we've heard about, which is the fact that we have different kinds of electric utilities where when we bring down a grid, we basically are bringing down the operations of a city and we're impacting basically the whole industrial complex. That's why electric grids are high targets, and they're targets for state-based agencies, and we're already starting to see that where a number of threats are out there right now, where we see these government entities and cyber actors targeting critical infrastructure systems with the view to disrupt the operations of the economy, as well as to actually go through and stop people from being able to go through and move around cities. Part of that challenge is it's also being coupled with the aging infrastructure and some of the challenges of the new technologies coming along. So we basically have electric systems that were built 40, 50, 60 years ago, and in some cases now we're trying to replace them all, but as we're replacing them, we're moving from analog systems to digital systems. As we start implementing these new digital systems with SCADA systems, we're deciding, should we be connecting them to this global network? How do we lock them down? And how do we go through and still manage all of the interdependencies between all of these systems together? It's a complex problem. So we basically have generation facilities. In California, as an example, we have new solar projects, which are distributed power gen. We have gas generation plants ending up on top of buildings in order to provide resilient power generation to the building itself. Coupling all this together with the transmission grid that's connecting it all, and then we start running into a new way of managing a very interconnected system. How do we now lock that down? Because it becomes, once you bring down one node and once you infiltrate one component of the system, you could potentially infiltrate the whole network. And that's hence part of the challenge of cybersecurity around the electric grid. So what we look at is we look at 3 different things in our security framework for helping to go through and think about how you can manage your electric organization, your electric utility, and think about all the cybersecurity infiltration points and how you can think about managing it. The 3 areas are access management. How do we control and manage all the different types of users and systems that want to connect into our environment? How do we manage the environment itself? Similar to how you would look at your power plant where you put up a physical perimeter around it with cameras, barbed wire, and concrete walls. How do we do the same thing in the virtual world where we need to go and put up different kinds of walls and also manage all the ingression points in that? And then the third is security, data security itself. Data is the key thing, where our power plants are, where our transmission grids are, how they're connecting to the houses, and then also the actual data themselves. What is it that we're doing in order to go through and have a generator or a turbine running, and what are the set points? And if we adjust set points on a system, we potentially can go through and make the turbine overheat and basically lose multi-million-dollar worth of equipment. So we're going to cover each one of the three items now as we go through this. So let's talk about access management. First, a little summary on that. Think about access in the light of what do we have in the way of systems coming in. So what's a system? A system could be your asset management system to try and talk to all of your SCADA systems. It could be access where we want to go and have a contractor coming in to be able to go through and monitor one of the transformers, or be able to go through and monitor one of the generation facilities. Or it could be one of your supply chain partners trying to communicate in with your financial system to get paid. Many different systems come in. Not only that, but in the electric world, especially where we have distribution grids, we have a large mobile workforce. How do we go through and consider all the areas of the mobile workforce and all of their access points, as well as the different players inside the office that need access? So let's look at access management then, a little bit more in detail. I like the quote here from Kevin Morley. Cybersecurity starts with the safe application of private networks. The one part I always like to say is access management is tracking, managing, and controlling authorized users into the system, into the environment itself. The challenge that we run into here is there isn't just one type of user. There is a privileged user, there is an end user, there is a contracted user, there's a corporate user. There's many different types of people. One of the key challenges we run into in access management is the God user, i.e. the system administrator who has rights to create new privileged users to get into systems. So one of the things that we are always looking at is how do we go through and manage our network and access into this communicated or linked infrastructure elements. So that's part of what we're looking at when we think about access management. So what are the challenges? What are some of the things that we need to do with that? Let's look at that. So here's an example. Ukrainian power grid. Worker credentials for the SCADA system were hijacked and basically allowed a hacker to get in and disable breakers. So what does that mean? It means that we're basically going to potentially have all the breakers crash and cause power outages. It could also create fires. There's all kinds of things that would do it, but notice that it was a worker credentials getting into the SCADA system. My question first off is, why is the SCADA system connected to a net? What SCADA system is connected to a network? And is that network public or private? Is it connected to the internet? And if so, why? We don't believe, as an example, that you should connect any of your SCADA systems to the public internet. There's ways of using private networks in order to go and do all that. So there's a number of elements that we want to do, but the key challenge here is there is an example of Target where one of their HVAC contractors went through and they gave away their credentials through a phishing expedition, and they were able to go and hack in through an HVAC system and get into the overall electric network inside a building. And what did that do? It allowed them to go and steal all of the data of the users and passwords of all the people inside Target, one of the largest hacking implements. Let's look at a little bit now on how we can solve this access management problem. So things we need to consider, as I've already talked about, is the different kinds of users. So if we think about a privileged user, they can access everything, they can change systems. They can change things to suit them, whatever they are, and that is a problem. So one of the key things that you need to do in order to mitigate the challenges of privileged users is don't allow them to access everything. Don't create super administrators, separate administrative rights into separate targeted groups. So a data administrator can have access to the database. A application administrator can have access to an application, but keep them separate. A network administrator can have access to manage the network, but keep them separate, and ensure that from a privileged user perspective, you've also implemented audit trail and multiple points of authority and policies and procedures in order to verify who are getting in and that all the people that are getting in have got background checks done. So what about the mobile worker? I'm going to go to the far right. Mobile workers, they're in the wild. They're in the public internet. When we went through and were using mobile systems in the past for electric systems, we never used the mobile cellular network. We used a private spectrum. Okay, and in that private spectrum, we went through and allowed we always used private networks. Now we're in the point where everybody's using a phone. They're trying to use their phone, the cellular network, in order to connect in. So how do we lock that down? So we can use private cell networks. We can work with our telco provider and get our own private cell AP, what we call an APN, in order to allow our phones to be on a private network connecting into our private environment instead of using the public cellular network. We can also implement VPN access from our devices. We can also access multi-factor authentication. That stops and provides a much stronger barrier for mobile workers to get into the system. And then the last one, the middle one, is the hardest one. The other ones I've talked about right now are things that we can do physically with technology. Office workers, and what we've seen a lot right now, is that they're already using a trusted device. They're in a physical environment that's already locked down. But what happens if somebody's able to infiltrate? Okay, so the challenge here is what we call social engineering, phishing for passwords. That means that somebody's sending out an email asking you to click on something, and all of a sudden when they do that, they're able to get access to your PC. They're able to go through and access your network passwords and usernames, and all of a sudden, they now have your privileged user rights to get into the system. That's a challenge because that's not something that we can necessarily test with technology. There is new ones. There's behavioral analytics coming along for office users on keystrokes, but what we always have to do here in order to mitigate this risk is make sure you have appropriate policies in place in order to go through and educate your staff that they should not be giving out, clicking on items and emails they don't understand, and that they are not subject to phishing expeditions. So what is the technology that you need if you're going to go through and set up an access management system? So we went through this exercise. We work with a number of large utility accounts as well as large corporate organizations. And when we've gone through and developed it, you have to look for a single sign-on technology. You need multi-factor authentication technology. You need things like directory services, Active Directory. You need to be able to segregate out your user repositories for privileged users from your end users. You need to think about how you go through and manage your privileged user access different than your end user access. You need to always be monitoring your access logs and be able to analyze those logs. You need to be able to authenticate all the devices connecting into the system. It's a very complicated problem. So there's a lot of different technologies, and in some cases, in this one example, there's probably about 20 to 40 different technologies you have to consider in order to put together an access management system for security. So to do that, that's one piece that you look at. Those are the things and the technologies you want to look at. When you're talking to your IT department, you basically sit here and say, hey, do you have all of these? What are we using? And who should in our organization be actually using that? And part of that is we'll share with you a little bit of some of the things that we take in the way of approach at the end of this to talk about how we kind of address that. But let's move on to the second item, environment management. So what's the environment? Part of it, we look at a little bit of the risks of the environment. The environment itself is the overall network itself and all the connection points to it. So we're talking about in a cloud environment, it could be systems that are running inside somebody else's data center, like Amazon, like Microsoft, or it could be running in a data center that you're leasing. All right, that's one part of the network. What else do we have in the environment? Well, we also have the network inside our generation plants. We also have the network that's connecting all of our distribution lines together. We also have the network that's connecting all of our transmission lines together. There is a lot of moving parts in this, okay? So how do we go through and understand all the different network access points and the environment itself? And I always think of it as you can sit here and lock down the physical power plant, but that power plant is still connected through a virtual or a physical fiber wire to an operations center somewhere. And it might only be within the power plant, but in most cases they're connecting out somewhere else. Why? Most of our vendors are sitting here saying, I want to see what's going on with one of my plant. If I got a maintenance contract with a supplier and they're basically managing my turbines, they sit here and say, I need to go through and see the production runtime data. So what we're going to do is we're opening up our power plants, we're creating an access point into that environment for our supplier, our maintenance operator, to go and look at the production data coming off of that generator. That creates a control system that can be hacked. So if we're looking at this, what are some examples? So this is kind of helping to go through and define a little bit of the risks. A US power grid, utility control system network was compromised. Okay, there was basically a system administrator software to administer the control systems was accessible via the internet. We've heard this. A lot of our SCADA systems are 20 or 30 years old. They're basically, the things that we as IT professionals think of as locking down cybersecurity is not necessarily part of the domain expertise of the engineering firms that put in the SCADA systems. So they don't necessarily think about all of the different access points and incursion points from your network that you need to be addressing. So when we look at this, we say, well, if we're looking at our control system and the network side, we should be thinking about locking it down as much as we think about putting a big concrete barrier around our generating plant. It should have that same level, but instead of being physical wires, it needs to be virtual wires. It needs to be virtual barbed wire. It needs to be virtual access control. So the system itself was exposed. What happens when you expose a power grid? You basically allow people to go in, and even though the wire might be connected, we can go through and turn off the flow of electricity along the wires. So what are the things we should consider then if we're looking at the network and the environment and helping to lock it down? Okay, from a cybersecurity network. So we always look at this in three areas: network design, network traffic flow and monitoring, and then the network access and routing. So let's understand, let's explain a little bit about each one. Network design, what are the things that you need to consider in your design of your network? Okay, a lot of networks are created to be flat networks that have a lot of trust relationships between different domains or subdomains, and it becomes a very complex environment. We've got one client right now where when we go through and are connecting in different networks together, we have to work with 4 different service providers to get all the different network engineers to make all the things talk to each other. Now that's complicated, that's complex. What happens is because we don't know all the different network engineers working on it, one person can break it just by doing a misconfiguration, but the other part is it also creates an incursion point depending upon how you've set up your routing. Okay, so the things that we look at in the actions from network design, the administrators don't necessarily understand all the systems because they are very vertically focused. Okay, so they don't look at it from a holistic point of view of my transmission grid, my distribution grid, my generation facilities, and how all the networks are going to work around that. And then what about my ERP system in the corporate office? What about my CRM system that might be hosted in Amazon? And then we've got our maintenance management system, which might be existing in another data center somewhere else. So the things we look at from the actions for network design, always look and think about network segregation. What does that mean? It means that inside your power generation plant, have a separate network. In that network, go through and make sure that the only thing sitting on that network is the equipment that you need there, and that it doesn't necessarily have a two-way in and out flow between it and, say, your corporate ERP system. Use proxies. What are proxies? Proxies hide everything behind it. So it means that we have another point that even if a hacker gets in, they can't just generally navigate the network. They're basically locked down by the proxy itself. Our rule, a little bit about network flow, and we'll get into that in the next work, in the next components there, is lock all the ports. So we leverage traffic routing rules and basically make sure that we use as access control lists, and we don't let network A or subnetwork A talk to subnetwork B. All right, let's talk about network traffic flow and monitoring. So things that we look at here, we've got lots of new streaming data sets coming on with a complex event processing. SCADA systems, in a lot of cases, we got one client right now that are putting vibration sensors on every single pump in every single area in a water distribution network. Okay, now what about electricity? Well, electricity, we can basically be going through and putting a sensor on every single transformer, and it can be a digital sensor. A digital sensor on a transformer allows us to go through and say, monitor what that transformer is now doing and looking for sparks that could be going just prior to it actually flipping out. Now, how often does that happen? Well, that data can be coming in every minute, every second, okay, every hour. But what we're doing is we're creating lots and lots of new streaming data sets. All that data needs to basically be managed, manipulated, and we start looking at what we call edge monitoring of all that. But the network data, we're introducing the new concept of 5G networks that are being rolled out as we speak today. These 5G networks allow us to have upwards of 10 gigabits of data connected through a cellular network. 10 gigabits is like streaming hundreds and thousands of movies in parallel. That means that we have lots of capability now to go through and stream data. How do we monitor all this traffic? It's like having a superhighway and trying to figure out all the vehicles going along and seeing who's inside every single one of those vehicles, because there are potential inflection points and there could be threats in every single one of those data packets. So we need to monitor the traffic. The actions we need to take here, monitor traffic for intrusion events. Not just the data and the content and the payload of the data, but how they package together, because that's what an event is. Monitor firewalls. Have more and more firewall infrastructure, and as we said, lock down the points inside. New technology is also emerging related to predictive network analytics. Now, what does that mean? As we start seeing behaviors of data packets coming through the network, we can start looking for anomalies. We can start doing things like basically applying it to the same way that consumers are going and visiting a store. Things that we do on the consumer side to do store management is no different than what we want to be seeing in the way of how electricity moves, and hence the data packets that are monitoring electricity moves. All right, so that gets us into the last part, network access and routing. So network access and routing is basically how do we go through? There's many organizations we've run into that the firewalls that come out when you first implement them, everything is open. By default, everything is open. That means that unless you close them all, you basically, and you've selected which ones to close, you've got to figure out which ones to close. We have a different rule. Ours is as soon as we get a firewall, we close everything. And instead, when we get it, we bring it in, you harden it up. Hardening means close all of the firewall ports. Then the only thing you do is you start now looking for which ones to open. The other part you start looking at is which ports do we open and why do we open them? And then when we do open up a port, especially in a firewall between, say, a power generation plant and corporate office, we look and say, all right, I only want to do that using what we call Internet Protocol or IP whitelisting. IP whitelisting is the IP of the firewall in my power gen is only going to communicate with the IP that we have in our corporate data center, and those are the only two paths that we can communicate. It creates almost a positive routing. So if you think about it like a highway again, it's like we're always going to exit on exit 517, okay? And that means that only exit 517 is the one that we're able to get off on the superhighway. The other things you want to consider are domain name services and using what we call private domain name zones, and private network connections. And again, similar to what we've got in the way of application proxies is using security proxies. Everything that we implement for our customers have always got multiple proxy infrastructures in a couple of different areas in the network so that we're able to go through and redirect network traffic and monitor at multiple points in the network. So hopefully that gives you a little bit of network in the environment. And we can't stress enough that part of network design is a key part of actually locking down your electric utility. So what are the technologies, again, that you might want to consider using here? You're gonna look at things like security proxy systems. So there's open source tools. There's also proprietary tools for proxy systems, but that's servers, and those are software agents. You need to look at traffic routing rules. You need to buy and make sure that your intrusion detection and your intrusion prevention technologies are up to date. You need perimeter firewalls. A lot of people use not one, but 2 or 3 layers of firewalls as well. And then you need to consider and make sure that you're using VPN, virtual private networking technology, or even what we even look at is private networks, using what we call MPLS or multiplex networks that basically are private. Instead of going through and connecting in and having your data center and your cloud, if you're using any sort of cloud technology, connecting in, don't use the public internet as your connection vehicle. Use a private network provided by a proper ISP. So the last area is data security. It's kind of like the onion. Every time we hear about a breach, we hear that somebody stole data. They went in, they accessed the network, they got through access control, they got into the network, so they were now able to navigate through all of those networks because the network might have been flat. And when they did that, they ended up finding a hole in a server somewhere that allowed them to access a database or allowed them to access a file directory. And in that file directory, they were able to grab a lot of data. And everybody says that the new gold is data. Well, the new gold is actually data with usernames and passwords. And even the bigger gold or the platinum is actually the privileged user name and password. Because if you can grab a privileged username and you can get access with that, that means that you can actually go through and change the security rules inside the system. So let's talk a little bit about data security. What is it? Data security is the way that we manage the integrity of the data and making sure that it is only accessible to the right people at the right time, and also that unauthorized parties cannot access it and that it doesn't get corrupted. So data security is not thing. It's not about just encryption, but it's also about where you need to go through and place the data within your network. And if you think about how governments work and intelligence agencies, we also need to think about classifying all of our data and understanding the different layers of confidentiality, personally identifiable information, as well as things like basically the passwords and usernames of privileged users or super users. So let's take an example here. I hate to say this one, but we all know, maybe we do know, that Booz Allen Hamilton, those are the guys that actually employed Edward Snowden. And part of the challenge here is everybody is looking and said, hey, let's go through and use different technologies out here because we're going to work on contracting jobs or consultant jobs, and we basically get data dumps. And one of the things that happened here is there was a defense contractor, had 60,000 files, including employee security credentials, and it was unencrypted passwords belonging to government contractors, and it was left on a publicly accessible server. Okay, well, was it an accident? It could have been, but that comes into the part about the policies and procedures on how to go through and manage all of your data sets. So the unencrypted passwords is a big deal. You should never have passwords unencrypted. Passwords should be what we call salted and hashed, and they should be stored in a very secure location and not just basically be given out. They should be stored in a proper directory structure that's locked down. Okay, but that's your issue. So the things that we look at, how do we mitigate the risk of managing data security? First off, let's come up with a plan for classifying our data. So we use a 10-layer data security model. Everything from publicly accessible data all the way through to top secret proprietary data, depending upon the organization you are. What is it that you need to do in order to lock down certain types of data sets? If you think about your privileged users and your security administrator is pretty much the most important person that you have that you need to lock down, because if you have your security administrator's username, password, and authentication tokens that get given to somebody else, they are able to go through and create all these different administrators that can get access to other things. So understand your data, the classification of it, your financial data, your proprietary drawings related to how the power plants are laid out, your security protocols for how to get into a power plant, the things that you're doing in the way of the maintenance jobs and maintenance schedules for when people are coming and going to the site. Those are all different kinds of data that you need to consider classifying, and then plan where you're going to store that. So a schedule for when people are going to arrive, what they're going to say, passwords they're going to use. You need to store that in a secure location. Where? Then we get into 3, segregate out your data storage network. So things like your privileged users, put your privileged users inside a subnet of a subnet of a subnet and lock it down and secure it, okay? Whereas when you're going through and doing publicly accessible data, I want to allow a customer to go through and look at their billing information. You're going to have to expose certain parts of that through a web system, but you don't want that system to necessarily talk to, well, you don't want that system to talk to your privileged. So you want to basically segregate out where you're doing it and also where you're going to store different data elements inside the network itself. 4, log and monitor all the data access. So when somebody is accessing, a system is accessing it, date and time stamp it. It's like looking at your log when people are coming to your power plant. They're basically signing in at the security desk saying, it's Joe from ABC Plumbing or ABC Electrical Services, and I'm here to do this kind of maintenance job. And there they are, they're going in, they're logging it, you've got that record. The key thing, though, is we need those as digital records because we need to start looking for patterns of behavior. But you want to log and monitor all the data access points. Who's accessing your enterprise asset management system? Who's accessing your SCADA system? Are they going through and doing things that are not part of their job? So is somebody going into the system, getting access to your power plant as a contractor, starting to navigate through because somebody left their computer open, and all of a sudden they're doing things inside the system that they don't necessarily know about? Okay, so we want to understand and log who's accessing it and where they're going, and then we want to undertake audits to understand where they went and trigger them. So if somebody's doing some sort of behavior that's out of the normal, then we trigger it and we say, okay, let's go and take a look at that. We have that technology available today to basically monitor all of that. So what are the kinds of technologies you need to consider when you're doing data security management? Well, encryption keys. Okay, we all heard about the encryption technology. It's called, there's RSA 256. There's also different kinds of new technologies. We always hear that, no, the government has the keys, public key infrastructure. So yes, there's all kinds of different techniques to go through and do encryption. There's different layers of encryption. Use the highest that you think is affordable, and that is at least 256 or higher. The other part is, when you're dealing with encryption technology, is make sure that you're always cycling through your keys as well. So you're not leaving them out there once and then letting them go for the next 5 years. You're cycling through your encryption keys, and you are coming up with a regular process of changing your keys. All right, what about this? Certificates, and that's part of that certificate problem. We start looking at where's the data residency compliance, things that you need to consider. If you're working in a legislated area that says, I need to keep all of my data in state or in country, where is it, and is it being done that way? Is it navigating across a network outside? Is somebody outside of the country accessing my system that I don't know about because I gave a contractor access to that? Part I've talked about already, salt and hash all your credentials. That means that never store unencrypted passwords. Don't even always go through and salt and hash your passwords. Classify and come up with a classification model for your data. And when you're thinking about what data is in what systems, make sure you know the classification. Based upon the classification, ensure that you're applying the appropriate policies and storage locations to lock all that down. And then also look at using hardware security modules. Things that will de-encrypt and encrypt hardware at rest, or all the data at rest, and in a secure manner, so that you basically, even if somebody is able to go through and get a hard drive, they can't decrypt it without having your hardware security module to decrypt it. So let me give a summary right now of all the things that we've gone through, okay? We've talked about the 3 areas for your security framework, things that you need to consider. How do I manage access from systems, from users, from privileged users? Number 2, how do we look at our environment itself? How do we put all of the barriers around our virtual world like we do in our physical world? How do we put up firewalls just like we put up concrete pillars? How do we go through and put all those different pieces together for managing the environment itself? And then 3, even though we've got the environment locked down, we put in the access protocols around how to get in and out, make sure that what's inside the environment is actually not easily readable, and that we are still encrypting it and managing where it's going and encrypting data back and forth between applications. So one of the key challenges we've ran into when we've seen all that is studies have shown that in order to go and implement what I've just described, you're going to need upwards of 70 different security vendors to go and put all this together. It is a large, complex problem, hence why we continue to see different security breaches happening on a daily basis. In fact, we don't even know all the different security breaches that are happening. A lot of them are being kept secret because they don't want the public to know what's actually going on and kind of ingression points that have actually been breached. So let's look at some of the things that we can do for this. So what we've done is we've looked at this and said, how can we go through and take those 70 odd parts and put them together as an integrated service? And that's what we've done with our product called FuseSecure. So we basically have looked at the best in the marketplace: Fortinet for firewalls, Gemalto for 2-factor authentication, or for encryption key management, SafeNet for 2-factor authentication. We've looked and said, all right, now how do we monitor all of those different data coming in and out of the network? Well, we use ingested, we do streaming technology like Spark, streaming storage infrastructure like Elastic. What about going through and processing all the data and being able to go through and scale out as more and more data is coming through our system that we need to monitor? Well, we look at using things like Amazon and Azure and that infinite compute capacity that's available in order to monitor, control, and analyze all of the data sets related to the security infrastructure. The challenge that we've run into, what we've found is 70 vendors is a lot. How can we go through and just deliver it as one suite? One service that you can use in order to lock down and manage the cybersecurity needs of your organization. So FuseSecure is a multi-layered security solution. It has access control in it, multi-factor authentication, single sign-on, all the procedures and policies and everything for privileged user management. We monitor it, we maintain a security operations center, and we also manage and help to go through and monitor all your data encryption at rest in transit, and we provide and link in through private networks for everything. The thing that you want to consider as well is, are your providers ISO certified? Are they security folks? Have they gone through the rigorous requirements to go through and get certified and audited as a proper security operator? That's ISO 27001. So our product is, and we basically go through and provide that level of support. So the things that you can do to get started. So we basically look at it and said, hey, we've got this product to do this, but you want to know, I still believe that there's a big problem in the marketplace today. And while people may or may not decide to work with somebody like us, they still need to go through and lock down the utility. I want to be able to travel to cities and feel comfortable that the electric grid is going to work, that my lights are going to be able to be turned on when I enter into my room. Okay, so the key thing here that you want to do is, first off, inventory your current security systems and tools. What are you using today? What's your IT shop using? What is your engineering group that's basically implementing your SCADA system put in place? How are you going through, and is that inventory comprehensive and covering everything? Number two, are there security? Determine if there's any technology gaps. We just gave you a list of all the different things to consider. Are they all being done? And if you've got gaps, what are they, and how are you going to go through and fill them in? And it could be getting 2, 3, 5, 10, or 15 more of those vendors of the 70 that are required to go and fill in those security holes. Then run a pilot for an area of utility and do what we call penetration testing. Let people come in that you don't even know that they're going to go and do this, and start testing it from a virtual perspective to see if there is points of access. See if there's ways people can go through, and they do phishing expeditions as a means to see if your people are truly following the policies of delete those emails and don't respond and click on things. So you're always phishing, you're doing your own people, and hire a firm to go through and run a pilot in your area. So those are things you can do to do a security review. Get yourself into the point and say, if I've got this running and I've got a pilot going, wow, now I can roll this out across my utility. I can run it across, generate all my generation facilities. I can then roll it into my transmission grid area. I can then put it into my distribution grids. So hopefully this was informative. I look forward to any questions you have right now, and hopefully we are helping to give you some food for thought as you try to lock down your electric utility. I think I'll let Carla wrap this up and share a little bit with what we're going to be providing in the way of additional information as we come forward, and be able to share some of the details of our presentation with you.
Great. All right. Well, just before we head off, I'm going to post our LinkedIn address in the chat box here. So feel free to follow us on LinkedIn. We regularly post any webinars, anything we're hosting there. And also, if you'd like to reach out to us, if you have any further questions, you can contact us at marketing@FuseForward.com. And I'm just going to post that here. So yeah, feel free to reach out to us on that email. I'll be following up with a copy of this presentation for everyone that's attended, so you can watch it in future as well. Thanks for joining us this morning. It's been great. Last call for any questions, and then we may finish up. All right, so thanks everyone. I will be speaking to you soon, and thanks for joining us this morning.